Good afternoon and welcome to the latest in this series of CQI webinars. Thank you very much for attending and for making the time to join us. Very pleased today to introduce a session on core tools presented by John Deadman and Jeff Vorley from QM&T. A brief introduction first to the webinar and then to the speakers, and then we'll proceed. First thing to note is the webinar will be recorded and a recording will be made available on the CQI website in the members area. Throughout the course of the webinar, if you have any questions, please use the question function in the control panel on your screen, and Jeff will be moderating and presenting those questions to John at the end of the presentation. Do feel free to pose any questions that you may have and we'll address them towards the end of the webinar. A brief introduction, if I may, to the speakers. John Deadman has a MSc in Quality Management and Statistics. He's a fellow of the CQI and a senior member of the American Society for Quality, certified quality engineer and Six Sigma Black Belt. He's delivered training and consultancy services in a large number of organizations, from SMEs to multinational groups, and we're very grateful to John for leading this session today. Jeff Vorley is CEO of Quality Management and Training Limited, which is one of the longer serving CQI and IRCA registered and accredited education centres, as well as starting out as a Rolls-Royce apprentice. He is a MCQI quality manager for numerous organisations and associate lecturer at the University of Surrey. The organisation QM&T was established in 1984 and has been a provider of quality products and services since then. As I said earlier, they're a registered CQI approved training provider offering courses in quality and audit. I think that's probably enough housekeeping for today. It's with great pleasure that I hand over to John to lead you in today's webinar on quality core tools. Thank you.
Okay, thank you, Alexander, and welcome everyone to this session. I will also mention that I've been actively involved in the core tools the past 27 years. It's a key area of my work. So the aim of this session really is to try to explain or make other organisations aware of this method, as you may wish to adopt this yourselves if you're not already involved with it. Just to add a little bit more detail about the QM&T services, we offer support not only for core tools, but for a wide range of topics, and that includes face-to-face training, distance learning. So we have different modes of support to offer clients, and some of these topics are also accredited by CQI and IRCA. So if we are able to be of any assistance, then by all means, you're welcome to contact us. Let's look now at the objectives of today's webinar. First of all, an introduction to the core tools, the role of the core tools within product and service realisation and life cycle, the relationship with quality management standards, industry expectations and customer-specific requirements, the applicability to different types of organisations, what organisations are involved with core tools, and some of the key elements and themes, and the benefits of applying core tools methodology. And for those organisations that feel that they would like to know more, but at the end of the session, perhaps take things forward, I'll be offering some guidance as to the next steps. Let's start with a few basics. What are the core tools? They're a best practice methodology supported by a series of key tools and techniques for introducing new products and processes into production. Originally, they were developed in the manufacturing sector, where they're still widely used. But one of the aims of this session is to draw attention to the possibilities of using them in service organisations, non-manufacturing organisations, because the principles apply to a wide range of organisations. Although the core tools can be utilised individually, they're most effective when they're applied in a coordinated way within a defined process for new product or service introduction. However, what do we really mean by the core tools? What are they? Typically, the major core tools are recognised as those elements that you can see on the screen. Advanced Product Quality Planning, or APQP, Failure Mode and Effects Analysis, or FMEA, Measurement Systems Analysis, MSA, Statistical Process Control, SPC, Production Part Approval Process, PPAP. So there are acronyms that are commonly used for the core tool. However, there are many additional best practice tools and techniques which are embedded within the above and support the above. But why were the core tools introduced? This happened in the early 1990s, and I'd like to explain some of the background to that using this next slide. And I'm going to spend a couple of minutes on this because I believe it summarises very well the role of the core tools. If we go back a step further in time to the 1980s, it was recognised within industry that many organisations worldwide in supply chain were not performing as well as was expected in terms of introducing new products and processes. This prompted some research to be started, and the output of this research is summarised by this diagram, this illustration that we're going to look at now, which is sometimes referred to as the camel curve, which will become clearer in a moment. It may look like a graph, but really it's just an illustration. The bottom horizontal scale, if you like, is time, and in relation to a new project, the left-hand side is planning and validation, the preparation, getting things ready, and on the right-hand side, we have the scheduled processing and delivery of the product or service. And in between these two stages, we have a vertical line which represents the start of processing and service delivery. On the extreme left of the screen, we have a vertical scale which describes the number of risks and changes identified during the life cycle of a product. The aim of the research was to identify the best performing organisations in the world and understand what they did better than some of the other organisations to set a benchmark and a model. And the outcome of the research found that these exemplar best-in-class organisations, which you can now see on the left-hand side of the screen, these organisations identified a large number of the risks and required changes at a very early stage of a new project. And they addressed them. And as the project moved to the right, towards the vertical line, to when routine processing was due to start, all of the risks and issues had been addressed. So that is clearly a good situation. However, a number of other organisations were not performing quite so well, and a rather different profile can be seen now, the red profile, which conveys to us that for many organisations, these risks, these potential problems, the need for change was identified at a late stage of the project, shortly before routine processing and delivery was due to start. And very often there simply wasn't time to address all of these issues. And inevitably, processing would start with outstanding issues that became a problem. And that, of course, initiated problem-solving activities, customer complaints, warranty claims, the things that most organisations particularly want to avoid. And it was recognised that if we go back to the left-hand side of this model, there's an opportunity to avoid these issues during the planning stage. And this prompted the core tools methodology to be introduced in the early 1990s. So let's have a look now briefly at some of the key core tools starting with the first one on the list that we looked at earlier, Advanced Product Quality Planning, or APQP. This is a generic term for the overall process of introducing new products and processes into production. It can be thought of as a type of project management. It comprises a methodical series of steps within which the core tools and other tools and techniques are utilised at the appropriate stages. It's not considered mandatory. It's a set of guidelines for best practice, which many organisations have incorporated within their own equivalent processes, often with some modification or revision to suit the needs and activities of individual organisations. However, it's quite difficult to visualise what is meant by APQP because it is a methodology. It doesn't actually have any tangible or physical form. However, on this next slide that we're looking at now, I've illustrated it as a table, which I think shows quite well what it comprises of. There are 5 key stages, 5 columns in this table, and these represent the life cycle of a project. The left-hand side, the first column, is the planning, is the initial kickoff of the project, the startup, and that takes external inputs from customers and stakeholders. But when that first stage has been completed, the output becomes the input to the next stage, and that follows through the complete model. The output of the previous stage is the input of the next. However, it is emphasised very strongly that these activities should start as soon as possible. And to emphasise that, in this example, I've superimposed the camel curve onto this table, as this shows the relative timing of these stages. So the aim is to start using these tools and techniques and identifying potential problems as soon as possible. And then as we move to the start of the project, that brings us to the red line, the vertical red line on the right-hand side, which is the end of planning. And now we hand over for routine processing and delivery, and things should be right. Let's look now at the requirements and applicability of the core tools. First of all, let's look at the linkage with typical quality management.
John, your sound has gone off.
Very sorry, everyone. Just having a minor technical issue. Please bear with us. We'll get John's sound back on in just a moment. Thank you.
Am I back on?
Yes, you are.
I'm back on.
Yes, you are, John.
Right. I've no idea what happened. Apologies for that. If I'm back on, I'll continue. Right. Requirements for utilising the core tools. They're used within a variety of industry sectors. At the moment, these are predominantly manufacturing sectors, but as I mentioned earlier, the principles can apply to non-manufacturing organisations. Some of these industry sectors have specific requirements for the core tools, which are included in relevant standards. For example, in the automotive industry, IATF 16949 requires some of the core tools to be used and strongly emphasises others. Many supply chain customers have requirements for their suppliers to use the core tools, and these are typically specified in what are known as customer-specific requirements, or CSRs. A customer-specific requirement is a documented quality management requirement or a set of requirements that a supplier must comply with when supplying that particular customer. And very often these include the core tools. A very key theme of the core tools methodology is the involvement of a multidisciplinary team. This is one of its great strengths. The aim is that the expertise within an organisation should focus on meeting the customer's needs and avoiding problems right from the very start. An alternative approach, which doesn't work as well, is shown at the bottom of the screen, where an organisation might operate on an individual basis with individual departments carrying out their activities, perhaps with rather less communication than is required. And often this leads to problems and issues being missed and results in complaints and failure costs that we want to avoid. Let's look now at some of the other core tools.
John, may I interrupt briefly? Maybe just revisit the slide for which we lost your audio for a second, just to make sure that everyone.
It's the linkage slide, John. It's slide number 11, I believe. That's the one, John.
There. That's the one. Right.
Thank you. If we can just talk through that briefly and then skip back to where we were. Thank you very much, everyone.
Yes. This slide illustrates the linkage of the core tools methodology with current quality management standards, such as ISO 9001. And within these contemporary standards, there are a number of themes which are strongly emphasised. You can see them listed on this slide, and I won't talk through all of them, but they include things such as customer focus, the risk-based thinking, continual improvement, things that many organisations will recognise. These are also the key themes of the core tools. So there is a very good alignment with the core tools and these key management system principles. So I'll move back now to FMEA. We're going to look now at some more of the individual core tools and techniques. Failure mode and effects analysis is another major core tool. Sometimes it's mandatory, other times it's strongly emphasised. What is it? It's basically a risk assessment tool. It requires a multidisciplinary team to get the best results. Based on the experience of the team consider, with this new product, this new process, what could go wrong? If it did go wrong, what would be the consequences, particularly the worst consequences? And where we feel necessary, what can be done to reduce the risk and avoid undesirable consequences? FMEA is typically applied to design activities and processing activities. Processing doesn't necessarily need to be manufacturing. And in fact, I'd like to briefly illustrate the FMEA methodology, and I'm going to use in a moment a non-manufacturing example. A typical FMEA worksheet is shown on the screen at the moment. There are various different formats used, but this one is quite typical, and normally there would be a number of pages. However, I've just shown one page as an example. The key features are shown on top of the form. It requires a multidisciplinary team. Lessons learnt are a key input. Things that have gone wrong in the past with similar products and processes could go wrong again in the future. But if we recognise that possibility, that risk, we've got the opportunity to avoid it happening. But we also need to identify new risks, and that involves considering any differences or changes with the new project or the new product. Key outputs of an FMEA are action to mitigate at least the biggest concerns, the most serious consequences or effects of things going wrong. The timing of FMEA is also very important. As illustrated by the camel curve earlier, it needs to begin as soon as even some information is available, and then it can be developed as more information becomes available. If it's left to a very late stage of the project, the chances are there won't be time to get the benefits from it. However, when it's considered to be complete, it needs to be maintained as a living document, because things do change throughout the life cycle of a project. So we need to keep it updated so that it constantly reflects the current situation. I'm going to illustrate the start of an FMEA. Unfortunately, we don't have time to work through a complete document, but I'm going to use a non-manufacturing process example just to illustrate that it's widely applicable. The left-hand column of the FMEA are the steps, each step in a process. I've only shown one step in this example, data entry. The function of this step is for an operator to enter data on a computer system. All of the process steps would be entered in this left-hand column, but I'd just like to focus on this one step. Once we've defined the process steps and we know what we want to happen, we need to consider the specific outputs or requirements of each step. So in this example, when data entry has been completed, what should have been achieved? And that's shown in the next column, headed product or process requirements. And here we enter the most important things that have to be achieved when that activity has been completed. Correct data entered correctly, complete data entered, data not mixed or corrupted. Once we know what we require to happen, we can then consider how might those requirements not be achieved? How might the intent of that process step not happen as planned? And that takes us on to the third column, where the team consider what could go wrong, the potential failure modes. Wrong data entered incorrectly. Typically, these are statements that reflect the opposite or the inverse of the requirements. They're statements of not achieving those requirements if the team recognise that this is possible. And then the team will consider, how could these problems happen? What controls do we currently have in the process to avoid these things happening? Do we need to reinforce our controls or introduce new ones? So the team will work through the FMEA, identifying the biggest risks in particular and deciding whether action is needed. So it is a very key opportunity to avoid problems in any type of process. However, we also need to be able to measure process outputs. This implies we need measurement or evaluation systems that enable us to judge whether these outputs are actually correct. So we've specified the requirements, but we need to evaluate and measure the outputs to see whether we've actually achieved them. MSA studies evaluate the capability of our measurement or assessment systems. There are a variety of different types of study used, but one of the most widely used types of study is referred to as an R&R study. And this refers to repeatability or consistency of measurements, and also to reproducibility, which are potential differences between people, equipment, methods. So that is a key study, combining those two elements. For some types of study, the correctness of the results, the accuracy, is also studied as well. This is typically done using some sort of computer software because there is a lot of mathematical calculation involved, which is easy using software once the data have been collected. A lot of the results are presented in graphical format, as we can see on the screen. And although there's quite a lot of information in this report, the key information is immediately visible in the top left-hand panel, where we have a simple bar chart. And in fact, the very first bar is the total gauge R&R. That is the overall result of the study. And the measurement scale used, just to the left, is percentage of measurement variation or error. And as you will probably guess, we don't want to have much measurement error or variation. So the lower the percentage, the better. This result is actually not very good because it's approaching 80%, and typical requirements within the core tools methodology are that we would like that percentage to be less than 10%. We don't expect the measurement system to be perfect, but we want to make sure it's good enough task. And this one isn't. So we want to be aware of that before we start using it. Let's look now at another statistical core tool, Statistical Process Control, or SPC. In a moment, I'm going to use another non-manufacturing example to illustrate the wide application of this tool. SPC comprises two main tools or techniques, two main groups of techniques. Control charts, which help us to understand whether a process performance is stable or in a state of statistical control. However, that doesn't necessarily tell us whether we're meeting the requirements. And in fact, usually or very often, we need to study process capability, particularly for very important characteristics, to check on how well we're meeting the specification. Let's have a look at an example of a control chart being used for a service process, a tourist information service, where customers walk into this, the office in the high street or wherever it is, and they require information. The data that we can see on this screen, which covers a period of 4 weeks, is plotting at the top, on the top chart, the average transaction time for a sample of 5 customers every day for the 4-week period. So those are average transaction times. However, what is this telling us? Well, we notice that there were a number of days where the average transaction times were less than is typical of this process. We know that because there are a series of data points which are below the green line in an unbroken run. And the green line, the green horizontal line, is the average or historical performance of this process. So for some reason, customers were served quicker than usual during this period. That's not a problem, but I'm sure the process owner would like to understand the reasons why. Maybe that's an improvement opportunity. But it's not all good news. If we move to the top right-hand corner of the top graph, the very last weekend, the Saturday and the Sunday, we can see that it took longer than usual to provide customers with the information that they required. We have 2 data points that are above the horizontal red line, which is a control limit. And that is based on the usual performance of this process, and it helps us to identify any points which are unusual in the context of the overall process. Again, I think the process owner would like to know, why were we slower in providing customers with that information? The bottom chart, the range chart, shows variation within each sample. And in fact, this is not particularly good news, because the right-hand side of this chart shows that there were a number of days when there was a lot of variation within each sample of 5 customers. Some were served quickly, some were served slowly. So there was a lot of variability, which is not a good thing. Again, the process owner really would like to know about that. The benefits of using a tool like this are that it enables us to understand process behaviour in a way that would be very difficult without plotting the data and actually seeing visually what's going on. So it's a very valuable tool for showing any unusual events. However, let's move on now to the other key area of SPC, which is process capability. And for this example, I'm going to use a manufacturing capability report. This is in fact more likely to be applied to a manufacturing company where there is a tolerance for a dimension of some sort or some other product feature. There's quite a lot of information on this slide, but the 2 vertical red lines in the middle chart, LSL and USL, that is the lower specification limit and the upper specification limit. That is the tolerance for a particular feature of this product. Data have been collected from the process and studied using this tool, and the variation, or the fit if you like, to this tolerance is shown by two bell curves or normal distributions. And we can see that all of the tolerance is being used up, and in fact the larger bell curve goes beyond the tolerance, which is not a good situation. This is normally described in numbers using a capability index, and there are various indices that are used which show different aspects of the process. These are shown in the right-hand panel, and one of the most widely used indices within the Core Tools methodology is the one at the bottom, the CPK index. And acceptance criteria vary, but the result that we can see of 1.09 is typically not considered good, and rather higher values are expected. So again, we want to know this before we start processing, find that we've got problems. Having completed the majority of the planning activities, we reach the fourth stage of the Core Tools methodology, which is the validation stage, stage 4, and the project should now be in a position to be trialled and hopefully signed off to confirm that everything actually is working as it should. A formal sign-off is typically carried out to confirm that the organisation has understood the customers' or end users' requirements, the product, the process, the service will continue to meet the requirements going forward during routine processing or service delivery at the volume or rate is required. Let's revisit the model that we looked at earlier. We've now arrived at column 4, phase 4, validation. I've shown again the red line where we sign off and move to the right to start processing, but how do we confirm that we're ready to do that? I've also shown the camel curve again to make that linkage that we looked at earlier. The prerequisites to completing stage 4, completing the sign-off, are typically these: a successful trial run of the process or service, the availability of validation data to demonstrate that the product or process or service really does meet the requirements under normal operating conditions. And in the context of a manufacturing process, it is usual for a production part approval activity to be carried out, often referred to as PPAP, which is in fact the 5th core tools on our list. And I've highlighted these key activities on the table. Let's have a look in a little bit more detail at PPAP. The requirements will actually be determined by customers. It's very much customer driven. However, there is a standard list of 18 records and items which are very often required. Sometimes less, sometimes more, but this is a fairly good representation of the requirements for PPAP. I won't talk through all of these items, but you can see that the core tools feature FMEA, measurement systems analysis, process capability. They're all embedded within this list. Following the process sign-off, when everyone has agreed that we are ready to start production, the organisation, the supplier, has the responsibility to ensure that future processing or service delivery continues to meet these same standards that have already been approved. The key process documents should be implemented to ensure this happens, and those will include things like the FMEA, work instructions, and so on, to make sure that the process is operated in a consistent way. Any changes to the design of the product, the process, the manufacturing site need to be formally evaluated and approved before implementation. Other stakeholders, such as the customer, may need to be involved in this activity. And one of the principles of modern management systems is that change equals risk. Things may have been okay when the product or the process was signed off, that if something changes, that could introduce a failure mode that wasn't there previously. So we need to validate changes before we carry them out, before we implement them. Ongoing activities throughout the product and process life cycle, the organisation are expected to engage in the following activities: obtaining feedback on any concerns and the need for any corrective actions if that should occur. Continual improvement, plan, do, check, act. Reduction in variation and wastage. Monitoring and evaluation of customer satisfaction as required in section 9 by ISO 9001. And capturing best practice and lessons learned. These will become the inputs to future risk analyses and future projects. And these help to implement continuous improvement as required by section 10 of ISO 9001. And the core tools continue to be used to support these ongoing activities. The benefits of utilising the core tools: they emphasise defect prevention rather than finding problems after they've already occurred. And we want to deal with these issues before routine processing begins to avoid customer complaints and other undesirable consequences. So very clearly, the core tools support the risk-based approach. They assist an organisation to avoid potentially high costs and other consequences which can arise from products and processes which do not meet requirements. And sometimes these consequences can be very serious. It enables new products and processes to be introduced in a timely manner with the aim of meeting customer or market timescales. And finally, they assist the organisation to satisfy stakeholder needs and expectations, including those of customers. So what should an organisation do to take the core tools forward? I'm going to offer a few guidance points on this slide. To implement APQP in the core tools, an organisation will need to establish an infrastructure as follows: ensure there is a clearly defined process for new product and process introduction, so that all the contributors, all the different functions of the organisation know what is expected from them and when they should be making their contributions. Establish a multidisciplinary or cross-functional team. This may be very small in small organisations, but it should be more than one person sharing the expertise which the organisation has and focusing on meeting the needs of all stakeholders. Provide core tools training and support for the team members. It is very important that all contributors understand how to use the methodology and the various tools and techniques so that they can use them effectively and in a timely manner. And assign responsibilities to team members for the APQP activities. Each contributor should know what are they required to do by when. So that brings us to the end of the slides, and I'd like to summarise what we've covered in this session. I'm going to revisit the original slide which showed the objectives. So let's check whether we've covered these, and hopefully these have been turned into learning points. We've looked at the introduction to the core tools. We've looked at the role of the core tools within product and service realisation and life cycle. We've looked at the relationship with management standards, industry expectations, customer specific requirements. We've looked at the applicability to organisations, and I will mention that the aim of the core tools, the vision of the core tools methodology, is that it is applied throughout a complete supply chain, from the highest tier to the lowest tier. And that goes down as low as raw material suppliers and off-the-shelf suppliers. Even they can contribute to these activities. We've looked at at least some of the key elements and themes, and we've looked at the benefits of applying methodology. So what is the next step now for any organisations that would like to know more, perhaps take this forward? Well, as I mentioned at the start of this session, QMT can offer a range of support services. face-to-face training and support, distance learning, we're available to assist with your needs. And that brings us to the end now of slideshows. And I think now we've reached the point where I'm able to answer some questions. And I think I might need to ask Jeff to step in at this point.
Yes. Okay. Hello, everybody. I hope you can hear me okay. Thank you, John, for that. That was fascinating. Well done. Core tools in 45 minutes. Well, less a bit because of the sound issues, but that's not bad going. Well done. Sorry about the sound issues. Believe it or not, we had done a core tools exercise 3 times before this without any problems whatsoever with the sound. So apologies for the breakup of the sound partway through. Issues with doing it live, I suppose, really. But anyway, let's have a look at some of the questions, and there are a lot of questions to get through. So, John, somebody is at. So I've got all the names for these, so apologies for the people that put these questions in. FMEA CT shows the AIGA, that's the Automotive Industry Action Group associated with this, and yes. VDA, that's the German association approach.
Yes.
Does it show their approach to core tools? You might need to explain that a lot of this is automotive, and I'm going to do some service ones in a minute.
It is. IIAG and VDA are both automotive support organisations, and they have tailored FMEA methodologies. And in fact, the core tools in general, they've tailored them to suit the needs of the automotive industry. And sometimes there are very specific expectations which may be a bit different from the general methodologies of using, for example, FMEA and process capability and so on. So this is where an industry have taken them on board and adapted them, and similarly in the aerospace and other industries.
Okay, why hasn't your FME included legislatory and regulatory, best word, it's easy for you to say, issues?
It does. It's just that I didn't go into that detail. There are 4 generic customer groups, at least within the automotive scenario. There's the organisation, the customer, the end customer, the end user. There are intermediate tiers of suppliers, including the OEM supplier, and there are government regulators, legal requirements, statutory requirements. And when the team assess the failure modes and the effects, they are expected to consider all of those customer groups. And it's possible that more than one customer could be affected, but there will always be at least one customer who could be affected by a failure.
Many of the tools are in Lean Six Sigma that you've mentioned. What's the parallel between core tools and Lean Six Sigma?
Well, core tools, there is a lot of overlap because many of the tools
in the tools,
techniques,
but the approach,
yes. Yeah. The Six Sigma is a support. It's a continuous improvement methodology. So the aim is that we can apply that during the core tools process. So, for example, when stage 2 is being carried out, which is design and development activities, one of the embedded core tools and techniques is DFSS, Design for Six Sigma. So there is a very close linkage between Six Sigma and the core tools, but also it is about ongoing improvement as well after process cycle.
Would I be right in saying, John, that Six Sigma, Lean Six Sigma is more about improvement and improvement initiatives, and core tools is about making sure that any new project or process or product is fit for quality? Is that a fair statement?
It is, and it's a plan, do, check, act cycle. We make sure that we've met the customers and all stakeholder requirements. We sign off the process, but that's not the end, because we're then expected to see continual improvement, and that could involve, that is likely to involve Lean Six Sigma or other improvement at Kaizen, other improvement activities.
people have got the core tools sorted for manufacturing in the sense of a new product or a new tweak to a product or a new sub-assembly or a new process, manufacturing process. They're all good with that. What would you do in terms of service? Where does it fit in terms of service? So if you've got new, how does that fit?
Well, as I mentioned on one of the earlier slides, the one that referred to the linkage with quality management systems, many of the key themes of a management system, which applies to any type of process, whether it be manufacturing or service, many of these themes also relate to the core tools. Customer service, plan, do, check, act, lessons learned, risk-based thinking, process approach, the whole list. Though this is not limited simply to manufacturing organisations, these are common themes for a wide range of processes. Therefore, the core tools and methodology can be applied. There will be tools and techniques within the methodology that are less likely to be used by a service organisation, but most of the methodology is applicable.
Is there any software for MSA or SPC?
Yes, there is a lot of software. There are basic Excel spreadsheets, various types that can be obtained from third-party add-ins. And the last time I looked at bespoke software packages, I think I came up with a list of about 400, but there are some that tend to be quite widely used.
Could you relate core tools to Kaizen, or is that a similar answer you gave to Six Sigma?
It's similar to Six Sigma, quite frankly. Kaizen activities support that we actually want to apply Six Sigma and Kaizen before we start processing as much as we can. So we use the best practice that we have at the moment. We try to introduce improvements even before we sign off the process. But that improvement activity continues throughout the life cycle of the project.
So it's a similar answer again. The Kaizen embraces many of the core tools that we've spoken about, FMEA and the improvement approach. But Kaizen is about an improvement initiative rather than ensuring that a product and a process, new introduction, is going to go smoothly for quality.
Yes.
Is that fair?
Yes, definitely.
Okay. Thanks, John. I don't know whether modesty is going to forbid you to answer this one, John, but I'll answer it for you if you like. Do you recommend a textbook? Could you recommend a textbook for this? There's only one answer, John, I'm afraid, and that's, I'm afraid, this is a question from the students, that you can buy John and my book associated with this. It's more to do with Six Sigma than it is to do with core tools specifically. And there's another book as well. You can pop along to QMT's website and have a look if you like. But I think John might say there are some books associated with it as well. Could you tell us about those, John?
So sorry, Jeff, could you repeat that? I had some noise on the headphones.
Yeah,
I didn't
sorry,
hear
I just mentioned a couple of books from QMT, but I think
I heard that. Yes.
Yeah, there's some handbooks about core tools, aren't there?
There are. The IIAG, the Automotive Industry Action Group, and also VDA, which is the German equivalent. Both of these organisations have published a range of manuals, which, although they were designed for the automotive industry, they've got broader application than that, and they tend to be used as generic manuals worldwide beyond automotive. And those documents can be obtained online, and they are good reference manuals. Those were the organisations that developed the methodology almost 30 years ago.
How long does PPAP or APQP take? If you, and bit of a how long, a bit of string question, but see what you can do with it, please, John.
Well, it is exactly how long is a bit of string. The spectrum is extremely broad. I've worked with organisations who have to turn around a product in just a couple of days, because that's the nature of what they do. They might paint a component, or they might cut a piece of material to length. At the other end of the spectrum, particularly with more significant products and processes, the project time can be 2 or 3 years before it's ready to go into production. So the way that the core tools are used varies greatly according to those needs. The very small, quick turnaround organisations will generally have generic applications of the core tools. Like, for example, they will have a generic FMEA that covers the scope of their usual activities, and they will have gone through the validation process that I've explained today. They will make sure that their process works for that range of products, even though the product range can vary. If a customer approaches that organisation with something new, that's when they need to revisit their planning and validation activities to make sure that they can actually achieve the new requirement. At the other end of the scale, with a very big project, there will be many meetings and validation stages, and that's simply the nature of the different types of organisation that are involved.
Have you bumped into a reverse FMEA at all, John? And if you have, could you perhaps talk a little bit about that? I don't know if you bumped into it at all.
Yeah, certainly. Reverse FMEA is actually another FMEA methodology, and it's a very general approach, which is not necessarily linked to. It focuses very much on the process FMEA, and the aim is that a team ensure that their process FMEA really does reflect the actual process conditions. So the team will hopefully have developed their FMEA with that knowledge, but we need to validate whether the FMEA is complete, has something been missed, and that involves walking the process. It's the kind of Gemba Gembutsu type of situation. Go and see, go out onto the shop floor, take the FMEA with you, talk to the operators. Are they aware of any issues or problems? Have we captured that on the FMEA? Actually check that what the FMEA says is really what is happening. And things do change over time. So reverse FMEA could be applied before we carry out process sign-off, and then it will be applied periodically during the ongoing life cycle of the product.
I'm getting lots of questions regarding whether the slides will be available, and they will be. John, could you just drop back one slide as well for me? I don't know whether you can do that for me.
Sorry, Jeff, which slide?
Just drop back one slide, that's just one back.
Go back one.
That's it, perfect.
Yes, right.
Got one or two questions about this as well. So you can CQI, IRCA provide, I don't know how many people are aware, but foundation, practitioner and professional qualifications as a qualification. And you can do these, find people that will do these QMT, obviously, amongst many others, who will provide you with these qualifications. Now, the core tools that John spoke about, there isn't a specific core tools IRCA CQI examination or qualification for those. It's buried in amongst all the other qualifications that are available for people to take advantage of, and there are some links there that if you would like to follow those links when you get the slides will become available to you via CQI, and Alex will be organising that, and Steph will be organising that, and Cara at some future date. So those slides will be made available to you. Okay, right. Can you explain the requirements of process documentation and work instructions? So John, what are the requirements associated with process documentation and work instructions?
Okay, there are typically a lot, again, I'm talking manufacturing industry now, and there are typically a lot of requirements for documentation. Some of these will be on the list of 18 items which are typically required for validation, i.e. the PPAP. but there are usually requirements for work instructions, visual aids, process setup sheets. I believe that in the automotive standard, I think I counted over 80 requirements for something to be documented. And in fact, I do have a list of that, actually. So there is a lot of emphasis on documentation, but also emphasis on showing that it really works through the validation and trial runs and so on.
Okay. Sorry, just give me a second. Just trying to find this particular question. Yeah, if you were wanting to do this for the first time, have you got any suggestions? So specifically, if you wanted to do APQP or PPAP for the first time, or FMEA for the first time, I suspect you're going to drop back to your previous slide, to the one we can see on the screen. And John, sorry.
Yes.
Any thoughts about?
Yes, certainly. Yes. It does depend to some extent on the current circumstances of the organisation, but what my initial suggestion would be that the organisation identify a new project, ideally one that they haven't started yet, and ideally one that won't require too much time to complete. In other words, tackle a smallish project if possible and try out the methodology and establish the organisation's procedures. If an organisation has already started a project, if they haven't progressed too far, it is probably still going to be useful to apply as much of the methodology as possible, just as really as a practice and a trial. There may be some information that we've missed the opportunity to capture it, but it may still be possible to pick up a project that's in the early stages. So that is normally the guidance I would offer a client.
With an APQP approach, is there a gate that you would expect to be implemented? Is there a gate stage at each of those stages with APQP?
Absolutely, yes. There are gate reviews expected at least at each stage, because the principle is that the completed stage needs to be reviewed, involving management. Any issues need to be discussed, and the ideal scenario is that the project doesn't progress unless the issues have been closed off. So gate reviews are a very key part of the methodology. And at each stage, documentation should be updated, records captured, because we're building up the evidence that's necessary when we reach stage 4 validation and PPAP.
Okay. Couple of questions. Can I have the qualification names? Just about to finish off then, Alex. Can I have the qualification that I just mentioned? Yes, Alex will be sending you the slides, and if you follow those links that you can see on the screen at the moment, you can see that list of qualifications that you can do either at Foundation and Practitioner. Last one, Alex. Can we have a full list of the PPAP, PPAP elements? Yes, again, that's all in the slide pack that Alex will be sending on to you. And just to round off, if you've got any other questions, there's so many questions. Sorry, I've not been able to. Hope I've done them justice. But if I've not, Alex will give you QMT's email address, and please feel free to email us and with your questions, and we'll do our best to respond. Thanks, Alex. Sorry.
Great, not at all. Just conscious of the time. I'm sure there's much more that we could go on to discuss, but I think now's time to put to a close. And to thank you, John, for a very interesting and insightful walk through core tools. I'm very impressed that we managed to do it in less than 40 minutes. So thank you very much for that. Thank you, Jeff, for your questions and facilitating the Q&A session with John towards the end, and thank you all for attending. Just a couple of parish notices before we go. As I've mentioned, the recording will be available via the members area of the CQI website. Also, if you are interested in pursuing CQI accredited training, visit our website and you can search the directory of CQI courses and CQI approved training providers, of which QM&T is one. We're continuing our series of webinars with the next on Tuesday, 14th of July, Natalie titled "Risks Ain't What They Used to Be," a songbook for quality professionals in return to work. I'd encourage you to attend that if you're able to do so. One final thing is a reminder to those of you who haven't already to get your entries in for the International Quality Awards. Entries close on the 31st of July at 1 minute to midnight, British Summer Time. This is a real opportunity to highlight your contribution to quality, to celebrate the profession. And Stephanie will be sharing a link to the awards pages in the chat at the end of the webinar. Just finally say thank you again, John. Thank you, Jeff. I hope you all found this session informative and useful, and we'll look forward to welcoming you to the next CQI webinar. Thank you all.
Thanks for the opportunity, Alex. Thank you very much.
Yeah, thank you, Alexander. Yes.
Bye-bye.